Welcome to 6.5, Dividing Polynomials and Synthetic Division. Today we're going to divide polynomials by monomials and make sure it's in simplest form. We're going to use long division to divide polynomials by other polynomials. And then we're going to learn about synthetic division. It's another way of dividing polynomials. So first off, just dividing a polynomial by a monomial. Remember, monomial is one term. So U and V and W can be numbers, they can be variables, they can be algebraic expressions. In fact, we have the exact same thing going on here. Now, I want you to keep in mind that if we're taking an expression that's two things added and we're dividing it by a single monomial expression, that means we can break it up. So that means U divided by W and V divided by W added together is the exact same thing. Same thing for subtraction. So what this is really saying is that W is dividing the entire numerator. In other words, the denominator is dividing everything in the numerator. So in these two examples, there just happens to be two things in the numerator. In this first example 1, though, there are three things. So I have a 12x squared minus 20x plus 8. This 4x is dividing all three of these items. So I can split it up into 12x squared divided by 4x. Next comes minus because I'm subtracting that 20x and it's over 4x. And then I have plus 8 over 4x. Now I simplify just like I did in section 1. So let's cancel out. Here I have an x and I have two x's, so that will cancel to 1x. Here my x's cancel, and I just want to make sure I simplify my numbers. So 12 over 4 is the same as 3 over 1. And in my numerator, I have 1x. 20 over 4 is the same as 5 over 1, and my x's have canceled. 8 over 4 is the same as 2 over 1, and there's still an x in the denominator. So simplified version, remember we don't have to write it over 1, so it's 3x minus 5 plus 2 over x. And now before we talk about long division, I just want to review how to do it. So it says to divide 6,584 by 28. So the 6,584 will go inside my bar and 28 goes outside. So now we need to ask ourselves, how many times does 28 go into 6? Well, it doesn't, it's too big. So let's check out 65. How many times does 28 go into 65? So that's about 2. And so what we do from here is we take 2 times 28, and when we do that, we get 56. So now I'm ready to subtract 65 minus 56. I get 9. Now I want to make sure I bring down my next number, so that's 8. Now I ask myself, how many times does 28 go into 98? And that's about 3 times, because 3 times 28 will give me 84. Remember, I subtract next, so I get 14. I'm going to bring down my last number 4. 28 goes into 144 how many times? It's about 5 evenly. 5 times 28 will give me 140. Now I subtract and I get 4. So my answer here is 235, but I have a remainder of 4. So it's 235 evenly plus 4 out of the 28. So I have two things here. The 235 is the whole quotient. 4 was my remainder. And 28 is called my divisor. Now I can simplify 4 over 28. So the simplified answer would be 235 plus 1 over 7. If you typed in your calculator 6,584 divided by 28, it'd be the exact same as this. You'll just get a decimal answer. So for some vocab, 6,584 is called the dividend. 28 is the divisor. 235 we said was the quotient. And 4 is the remainder. And it kind of outlines over here, this is taken out of your book, the steps that I use to solve this long division. So these steps are going to be the exact same with polynomials. So we did it over here with two integers with just numbers. Now we're going to look at how to do it in a polynomial setting. I give you a 1, 2, 3, 4 step outline. Again, this is taken out of your book. But we always want to make sure that we write the dividend and divisor in descending powers. So that means highest power to lowest power. It's like left to right. Step 2 is putting placeholders for zero coefficients. That means when we're missing a power, we need to make sure we have a placeholder for it. And we'll see one of those in example 5. Step 3 is perform long division like we did in the slide before, like we did with the integers. And step 4 is just continue the process until you find a remainder. So let's start with this example. I put my dividend inside the house. Actually, guys, fun fact about me, in 3rd grade, my teacher had us all come up with a jingle to help us remember dividend, divisor, and quotient. And so my jingle was dividend in, divisor out, quotient is the answer, so shout it out. I don't know, I thought it was pretty clever, and she still uses it to this day. So we have dividend inside our house, so that's our numerator. X squared plus 2x plus 4. We'll put our divisor outside the house, x minus 1. Now to start off, we need to ask ourselves, how many times will x, this first term out here in my divisor, how many times will x go into x squared? In other words, I want you to think x squared divided by x would give you what? And the answer there would be x if you cancel out an x in the top and an x in the bottom. So x is going to have to go above the x term, okay? So I don't want to put x above the x squared term. I want to put it above the x's, okay? So now I multiply, just like I did on the last slide, x times x minus 1. Now remember, when we're doing this, it's times all of it. So think about it as in parentheses. So x times x would give me x squared. I'm going to line it up with the x squared. X times minus 1 would give me a negative x. Now, just like in long division, I'm ready to subtract. And again, I'm subtracting all of this. So I like to put it in parentheses. So I remember I'm subtracting the x squared and I'm subtracting a negative x. So x squared minus x squared would give me 0x squared. I'm not going to write 0x squared because I don't need to. It's redundant. Now I have 2x minus a negative x. So that would give me 3x. And after I'm done subtracting, remember we drop down our next number. Here it's a plus 4. Now I'm going to ask myself, what do I need to multiply x by to get 3x? So what I want you to think here is 3x divided by x equals what? And the answer 3x divided by x, the answer would be 3. So I need to write a 3 up here. So just like we did in green, the next step would be to multiply this 3 by the x minus 1. So 3 times x would give me 3x. This is good. And 3 times minus 1 would give me minus 3. Now remember, I'm putting this in parentheses because the next thing we have to do is subtract. We're subtracting all of it, not just the 3x, but we're also subtracting the minus 3. So 3x minus 3x, good, that will cancel. 4 minus a negative 3 would give me 7. Now I'm done. This is my remainder. There's nothing else for me to drop down. So my final answer, remember, it gets written as my quotient, x plus 3, and then it's always plus our remainder over our divisor, which is x minus 1. And I want to make sure this is simplified, and it is. There's nothing I can cancel with the 7 and the x minus 1. So remember, this 7 is the remainder. The x minus 1 is the divisor. And this guy here was the quotient. Let's look at example 4. So sometimes they're kind of evil and they don't give it to you in standard form. So we want to make sure that we write this in standard form before we do anything else. Now we're dividing this polynomial by this polynomial, which means my long polynomial goes inside my house and my little polynomial goes outside. So if I'm doing my little polynomial in standard form, the x term would have to come first. And remember, we want to keep the sign that's in front of it. So it's a minus 2x and a positive 3. Now inside here, oh no, goes my standard form polynomial. So the highest order is a positive 10x to the 4th. The x to the third term is minus 13. There's a minus 7x squared. And then an 8x. And then a positive 4. So now that it's in standard form, I'm ready to do my long division. Remember, the first thing we do is ask, how many times does negative 2x go into 10x to the 4th? The other way to think about it is, what do you need to multiply the negative 2x by to give you 10x to the 4th? In other words, what's 10x to the 4th divided by negative 2x? Well, that answer would be negative 5x cubed. Notice how I'm putting that in above the x cubed spot. Okay, I didn't put it above the 10x to the 4th. So now I'm ready to multiply negative 5x cubed. Now it's times everything, the negative 2x and the 3. So negative 5x cubed times negative 2x would be a positive 10x to the 4th. Remember, we can multiply the numbers, negative 2 and negative 5, to get positive 10. And an x cubed times an x would give me x to the 4th. But I'm not done. I need to make sure I take negative 5x cubed times the 3. So that'd give me negative 15x cubed. I'm ready to subtract. This is the step that most people mess up on. You're not just subtracting the 10x to the 4th, you're subtracting the negative 15x cubed as well. So I'm going to put it in parentheses just to form a good habit so I don't forget. 10x to the 4th minus 10x to the 4th would cancel. Negative 13x cubed minus a negative 15 would give me 2x cubed. Remember, after we subtract, we drop down our next term here. It's a minus 7x squared. Okay, now I'm ready to ask myself, how many times does negative 2x go into 2x cubed? In other words, what do I need to multiply negative 2x by so that it gives me 2x cubed? If you don't like to think about it that way, think about 2x cubed divided by negative 2x. What would that give you? Well, it would give you negative 1x squared. Now, check and be sure this is okay by your next step. So when you take this negative x squared and you multiply it back, what is it going to give you? Well, take it times the negative 2x, you get a positive 2x cubed. Taking it times the positive 3 would give you a negative 3x squared. Now you're ready for the subtraction step. Make sure you put it in parentheses. Positive 2x cubed minus a 2x cubed would cancel out. Negative 7x squared minus a negative 3x squared would give you negative 4x squared. And now you're ready to drop down your next term. Now you're ready to see, what do you need to multiply negative 2x by to give you negative 4x squared? In other words, think, what's negative 4x squared divided by negative 2? So your answer is going to be positive 2x. Because when I multiply this back, a 2x times a negative 2x would give me negative 4x squared. And a 2x times the 3 would give me 6x. After I multiply it back down, I subtract. A negative 4 minus a negative 4, the x squares cancel. 8 minus 6 would give you 2x. Drop down your very last term. Here it's a 4. What do you need to multiply negative 2x by to give you 2x? In other words, what's 2x divided by negative 2x? That would simplify to just negative 1. Multiply it back. Negative 1 times negative 2x would be a positive 2x. Negative 1 times positive 3 would give you negative 3. Again, subtract. The x terms cancel, and 4 minus a negative 3 would be 7. So after you've dropped down everything, the 7 is your remainder. So your final answer is your quotient, negative 5x cubed minus x squared plus 2x minus 1. And then it's always plus your remainder over your divisor. So negative 2x plus 3. Missing powers of x. So here's example 5 that I was talking about earlier. Notice that my x cubed minus 2, it's in standard form, but it's missing some powers, right? It's missing some powers. There's 0 x squares and there's 0 x's. So I want to make sure when I do my long division, I have placeholders for them. Placeholders are important. It would change our answer tremendously if we forgot them. So let's do long division again. X times x squared would get me back to x cubed. And I also need to take my x squared times my minus 1. So I'd get negative 1x squared. I want to subtract all of this. X cubes cancel. I have 0 minus a negative 1x x squared. So that's like 0 plus 1, so x squared. Drop down my next term, even if it's a 0x. X times another x would give me this x squared. Multiply it back. So x times x, like I said, is x squared. X times -1 is -1x. I'm ready for the subtraction step. X squares cancel. 0 minus a -1 again is a positive x. Drop down my -2. X times what would give you x? Well, x times 1 would give you x. So 1 times x is x. 1 times -1 is -1. I subtract. -2 minus a -1 would remain me with a -1. So final answer, x squared plus x plus 1 plus remainder over divisor. Now, there's another way I could write this. Instead of plus this -1, I could write it as -1 over x minus 1. So instead of plus a -1, I could write it as subtracting a +1. Either way will work. A second degree divisor. So far we've only looked at when the power was 1 on our divisor, but now let's look at when a power of 2 happens. So same thing. Might have to give myself more room here. I want to make sure I'm in standard form. Change color. X to the 4th plus 6x cubed plus 6x squared minus 10x minus 3. I want to make sure I'm not missing any powers. So a 4, 3, 2, 1, and 0. And I'm dividing it by x squared plus 2x minus 3. So let's follow our same order here. We're checking only the first term, so the x squared. What do I need to multiply it by to get x to the 4th? I need to multiply it by another x squared. So I want to put that above the x squares. I'm not going to put above the x cubes or the x to the 4th. X squared goes above x squared. So now I'm taking this x squared and I'm multiplying it by the 3 terms in my divisor, all of this. So x squared times x squared would give me x to the 4th. X squared times 2x would give me 2x to the 3rd. X squared times a -3 would be -3x squared. Now I'm ready to subtract. I'm subtracting all of this. x4's cancel. 6 minus a +2 would be 4x cubed. 6 minus a -3 would be 9x squared. Don't forget, we need to drop down our next term, so -10x. What do I do from here? Well, remember we want to ask ourselves, x squared times what will give you 4x cubed? Remember, the other way you can think about it is 4x cubed divided by x squared. What's that going to leave you with? Well, it'll leave you with a +4x. So 4x times x squared is 4x cubed. 4x times 2x is an 8x squared. And 4x times a -3 is -12x. I'm ready to subtract. Remember, I'm subtracting everything. So my x cubed terms cancel. 9 minus 8 would be an x squared. a negative 10 minus a negative 12. That's a positive 2x. After we subtract, we drop down the next term and ask ourselves, how many times does x squared go into x squared? Well, just once. Think about it as x squared divided by x squared. That would cancel and simplify to 1. So I'm taking 1 times all 3 of the things in my divisor. And when I do that, I get x squared plus 2x minus 3. Subtracting this would leave me with 0, 0, and 0. So when my remainder is 0, when there's nothing there, that means it is being divided evenly. Okay, so this big long polynomial divided by x squared plus 2x minus 3, it goes in evenly. And my answer is just my quotient. There is no remainder. Now, synthetic division is an alternative to long division. And it's a little less sloppy because it doesn't involve the variables. It just involves the coefficients. This diagram right here is going to be helpful to you, especially this part, the vertical pattern. Vertical, remember, means up and down. So terms that are up and down you want to add. The diagonal pattern, diagonal means across. You're going to multiply by k. So notice that we have a polynomial, ax to the third, bx squared, cx, and d. A, B, C, and D are the coefficients. They're the numbers in front of the x's. So we fill in with just our numbers. Remember, we're not using x anywhere here. K is the number in your divisor. So you have x minus a number. Now notice, it looks like a negative k, but really you put a positive version. So what I want you to think is this k. Always think of it as the opposite of what you see in the divisor. So I see a negative k, I want to put a positive k. If it was x plus a k, I want to make sure I put negative k out here. And you'll see what I'm talking about in the examples to come. So this is example 7 out of your book. It says to divide x cubed plus 3x squared minus 4x minus 10 by x minus 2. So in order to do synthetic division, you want to put kind of an upside down division bar. And at the top, we're going to fill in with our A, B, C, and D. So here's our A, B, our C, and our D. What's the number in front of x here? It's imaginary. It's an imaginary 1. So we put a 1 up top of our box, leave some space down below. Next comes our b, so that's the coefficient in front of the x squared, so we put a 3. Next would be a negative 4 for our c, and a negative 10 for our d, and apparently I put b, it's supposed to be d. Okay, so we filled in a, b, c, and d, the coefficients of the dividend. Now we want to put a number out here outside, and that number is going to be k. So k comes from your divisor. We're dividing by x minus 2. So I see a negative 2. That means I want to put a positive 2 outside. 2 is my k. Now, to start synthetic division, you always want to drop down your first coefficient. So I'm dropping down a 1. Now, remember we said diagonally we're going to be multiplying by k. So you're taking 1, and to get your next number up here, you want to multiply it by the k. So what you're doing along here is you're taking 1 times 2. And when you do that, 1 times 2 gives you 2. Now, what did we say we were going to do vertically? What's our vertical pattern? we're going to add these terms. So 3 plus 2 gives me a 5. Now I'm ready to go diagonally. So diagonally, we're taking this number times our k. That means I'm taking 5 times 2. 5 times 2 would give me a 10 here. Now I'm ready to go vertical. I want to add a negative 4 plus a 10 would give me 6. Now I'm ready to go diagonal. I'm taking 6 times my k, which is 2. 6 times 2. And I get a 12. Now I'm vertical, so I want to add. Negative 10 plus 12 would give me a 2. These are the coefficients of my quotient. The last number is always your remainder. So let's look at our coefficients. We have 1, 5, and a 6. 2 is our remainder. Remember, our answer will have the remainder over the dividend. What was our original dividend? X minus 2. And now we're ready to put our quotient out in front, just like we did before. We have 1, 5, and 6. So how do I know what x goes with them? Is it 1x cubed? Is it 1x squared? How do I know? Well, I kind of do it in reverse. So I start with my 6. My 6 has to have no x next to it. So this term right next to my remainder doesn't have an x. And then you just go up from there. So this positive 5 would have 1x. And then this positive 1 would have an x squared. So my coefficients go 1, 5, and 6, and they're all positive. Remember, I have my remainder over my dividend. Let's look at a couple more examples just to get the feel for this. I really think once you get a feel for synthetic division, it becomes pretty easy. So we want to do our upside down division symbol. We could put our k out here first. So remember, it's always the opposite of whatever you see. So look at your divisor, so your denominator. If you see a positive 4, you want to make sure a negative 4 gets put as your k. Now I fill in with my coefficients of my numerator or my dividend. I see an x cubed, and the coefficient of that is 1. X squared coefficient is 3, but where's the x coefficient? Well, there's 0x here, so the coefficient for x would be 0. I want to make sure I put that in there. And then we have a minus 1. Okay, so leave yourself a note that this stands in the place of, it's a placeholder for 0x. Okay, so let's remember what we do first. We drop down our 1. Then on our diagonal, we want to make sure that we multiply. So remember, we're doing the 1 here times the negative 4. 1 times negative 4 would give me negative 4. As soon as I'm vertical, I want to add 3 plus negative 4 gives me negative 1. I'm going to go diagonal. I'm going to take the negative 1 times a negative 4, which will give me a positive 4. Now I add 0 plus 4. I'm ready to go diagonal. I'm ready to multiply. 4 times negative 4 is negative 16. Add these, negative 1 plus Negative 16 would be negative 17. Now remember, this last number is your remainder. These three are your coefficients. So we're going to have a 4, and it's positive, a negative 1, and that has an x value with it, and a positive 1, and that has an x squared value with it. What do I do with my remainder? Remember, I want to write it as remainder over my dividend. The other way you can write this, instead of plus a negative 17, is subtracting 17 over x plus 4. And I want you to pause the video and try the last one. All right, hopefully when you did that last one, you got 5x squared minus 10x plus 26 minus 44 over x plus 2. If you did not get that or have questions about how to do it, check my work. If you still have questions, raise your hand and please ask.